Hi, welcome to track 0. We're gonna work on the floppy drive thing a bit more. What's that? I have a new camera. I have a new camera. I'm the one. I'm the one who set it up. I am. I should know. I'm just talking to myself in an empty room. Really? It's over here. Oh, okay. Well, hi everyone. So last time we tried to be brave and do a floppy sector read deal, but it didn't work. The weird thing is, well, let's do the usual. Good evening, Wereworm. Let us do the usual. Power it up, show you what it does. Deal. Again, that's the floppy doing that by itself. That is none of our doing. So when it powers on, it resets itself, it recalibrates itself, it seeks to track 20, and then it appears to deploy the heads, and then just spin there. Now, I don't know that it actually is deploying the heads. I might want to actually watch this time, because it was late when we got to this last time. Oh, it's actually going to seek to track 0, because we're trying to read sector 0. Anyway, let's see what it does. So it resets, and actually, I'm not sure it does deploy the heads. I'm not sure there's a difference on a 3.5, 3.25, 5.5, 5.25, 3.5, 3.5 on a 3.5 inch floppy. I'm really not. I'm not sure that the head ever is not engaged. So that might be neither a good thing nor a bad thing. But anyway, it doesn't seem to be doing much of anything. It seeks to track 0 and then it hangs out. So we start debugging is what we do. Oh, Wereworm says sounds a bit off. Only right channel works. Interesting. Oh, I can actually see that. Oh, there we go. Sorry. My audio setup is quite janky. I'll describe it because I never... Oh, wow. Very janky, apparently. Hello. Hello, test, test, test. Okay, you saw that, right? Oh, the XLR input was on. Yeah, so I've got this whole thing. I've got a mic here. The mic runs all the way back to my little shitty recording studio where I have a 32-track mixer that I bought because I'm dumb. And then 2 channels of stuff, 2 buses, come out this way, come all the way back to a little Porta studio here that has sound going to a pair of speakers over here and into this machine. So I use it for like listening to records and routing it over here, and also for piping the mic into the computer from over there for no good reason because I'm insane. So it's yeah, it's janky. Okay, anyway, so oh right, my first thought, because I was gonna say debugging and we'll just dive into debugging, but no, there is something really dumb that I want to check out that I kind of feel like might be the case, which is, did I increment the index registers in my sector read code? I feel like it's possible that I totally did that because I was rushing, which would make the things loop forever because it's waiting for the register to roll over. Let's find out. You know, if I'm this excited about it, and I'm like, ooh, that might be the case. It's not. It's not going to be the case. Also, we're going to have to re-pull up everything because I managed to pull the power cable on my machine last night. I mean, I guess I should probably really be killing this machine every night anyway, but yeah, that was a whoopsie. Where are we going? Let's just look for FDC stuff until we get to the right area. Sure. Okay. This is the right area. No, thank you. I don't need any extra shit. Okay, I set up the addresses. Cool. I set up the parameters for the command. No, I am totally incrementing Y. What a disappointment. I don't want the latest Visual Studio Code update. Not right now. I'm in the middle of a stream. Come on, man. Okay, well. Exactly as I said. If I was so excited about it, then it probably would not be the case. Ah, well. Jacob says, is the top part spinning on that drive that was standing sideways? That's the drive motor, and it is. Has been for a while. We got the drive motor turned on many episodes ago. I actually don't know how many. So this is episode 38, I think. If I just tap that in, we are dangerously close to 40, and that is horrifying. What a great view. I think that's my basement floor because my webcam fell on the floor. Anyway, yeah, we're doing some stuff. Worm said, just put some distributed computing screensaver on it so you can say the computer stays on for cancer research. Yeah. Is folding at home still a thing? Should just do that. Anyway, I guess I'll do the thing where I just start writing things. Oh, I will say, before I start diving into just putting breakpoints all over the place, I feel fairly good that, potentially, we will be fast enough. So I was a little bit worried at first because I said, so the drive is set to 500 kilobytes. Well, here's the thing. It's set to 500 kbps transfer speed. So that's how fast the serial data is coming off of the floppy disk, right? And I thought to myself, is that kilobytes or kilobits? Because if it's kilobytes, and I did the math, that's way too fast. It's literally, if 500, so that would be 500,000 transfers per second, versus I checked it out, the NES runs at like 1.75-ish megahertz. So you have like 3 and some cycles, just not instructions, cycles, clocks, in which to read a byte off the floppy. And I went, fuck, that's impossible. I then checked and said, is it bits or bytes though? And it's bits, which again makes sense because it's reading a stream of serial data off the floppy. And it is kilobits, which means we have more like, it depends on, I can't remember if I did my math right, but basically what I had come up with is, if I am thinking about it right, then it's like we have 30 cycles to read each byte, which I think is totally manageable. If not, we have 15, which is still pretty good. Because basically what we need, like, let's see. I mean, I guess there's the waiting for that register to become available, which is like at least 3 instructions in and of itself, if it succeeds. Which we assume, if the thing is full and we're trying to keep up with it, then it should be pretty much full when we hit it. So that's like three instructions, I think, for like reading that register, anding it, comparing, and then the branch. So actually like 4. Ooh, like a branch and a return, actually. So that's more like 5. That's pretty fat. Regardless, that's still, if it's like 15, we're still, if it's 15 cycles, actually. Oof, that's where I'm, because I think I was saying, I mean, we could just figure this out and we'll see what happens, but 30, if it was 30 cycles, and we assume that each instruction takes like 2 or 3 cycles to complete, then that tells us we've got like 10, 15 instructions. So we're at like half of our instruction budget if it's on the low end, where it's like 10. And then we have the store here. That's another instruction. Probably, I would say this is probably 3 to 4 cycles. I could look in the book, but so we're getting close. Increase Y is definitely going to be like a 2-cycle command. It's going to be read and increase, and that's it. And then the branch, which again is going to be kind of fat. So we might be pushing up against the edge of it, but if we have to, there's optimizations to be made here. So we might not be totally screwed. But if not, if we have to drop down to 720K double density floppy, that's also fine. And that doubles our budget, which means that we would be well within it. Dave says indirects are like 5, 6-ish. Whew, gross. Yeah, we'll see about that budget. regardless, if we have to drop down to double data rate, that's fine. Wareroom says 60-ish cycles, I would have guessed. At 500 kbps. Let's do this math again real quick. It's really, we're kind of wasting time, but why not? So we know we have 500 kbps, right? And let's see, if we divide that by 8, you know, here, it's PowerShell. Let's use variables. So, data rate is 500,000. And byte rate, which might be even slower because I don't know if that 500 kbps is the raw speed of the bit stream on that disk, because there's a lot of fat in that bit stream that we will never see. So it could, you know, be an even bigger divisor factor. But if we assume it's only, you know, 1 to 8, then that's data rate divided by 8. And then, let's see, so our cycles per second is, like I said, is close enough close enough for jazz is like 175. 175, yeah. So that means, so our byte rate was 6,000 or 62,500 bytes per second. And I mean, I guess if we just do cycles per second divided by the bytes per second. Whoop. That gives us 28 cycles per byte. So I was right. I don't know where you pulled 60 out of. Now it could be because you are doing, you know, because it is fuller fat and that divider is much bigger than 8. But yeah, so like 28 cycles. It's possibly doable. We might have to drop down to double density. Okay. Wareworm, was it 1 byte every 1.6 microseconds or so? Yeah, they do give information in that kind of term somewhere, and I don't know where, so I'm not going to go searching for it, but I do think I saw it. Not that I remember that number in specific, but I remember things being given in that format somewhere-ish. Might be in the OS Dev wiki. Anyway, here's what I want to do. Here's what I got to do. The first thing I want to do is I'm just going to keep doing that because it's worked well for me so far, where I'm just going to steal this jump to monitor code, and I am just going to jump into the monitor earlier and see, you know, firstly, let's just put one right after our setup commands to see if any of these are hanging, because that is totally a possibility where, like, the floppy drive, you know, we're not doing setup right or something, and it's not expecting a command byte, and then we're sitting there waiting for it to, you know, be ready for a command byte, and it's, yeah, no. So let's just do that real quick, like, because sometimes a brute force is the way you gotta go. The ill-named link.ps1. All right, while that builds, let's do something. Power this up, and power this up, and pull this out. Jacob had said Dreamlab or something like that. Is that a similar folding at home type thing? I've never played with any of those. I mean, it's not like it would do anything for me. It's not like it would be anything for me to look at, but I do find them interesting. Right, let's go program a thingy. I'm expecting my programmer software to be up, and of course it's not, because I pulled the power cable on my computer. Browse for a file. It's called basic bin. Open it up and put a 1 within. Hit OK and clear the check ID. That's how you program. That's how you program. Also, I don't know if I had mentioned that Taco Man says, hey. Wareworm says 4 megahertz. On what? What is 4 megahertz? Quattro says, hi, man. Hi, Quattro. Ooh, interesting. Sorry, I know I'm going off camera, but Dave is giving me interesting cycle information. 0 page is 3, indirect is 5, indirect X is 6, indirect Y is 5 or 6. I guess probably depending on if there's a carry. Implied is 2. Absolute X is 4 to 7. Gross. Jacob says, volunteer and compute. Now, is that the name of another thing, or is that a description of that category of software? I don't know. Let's stick this in and see if we get to the prompt. Which, if we do, then that at least means that our setup for the command isn't totally screwed. It could still be somewhat screwed, but not totally screwed. Drive on. Power on. Okay. All right. So it probably is the us waiting for bytes bit. Daniel Rodriguez says, hello, hello. Hello, Daniel. Okay, let's pop it out and move it. And let's see if we get past the first block of transfer. You know what I mean? If that first 256 byte loop works. You know, it also might just be that we are way too slow, and it's erroring out due to an overflow, and then we're just not dealing with it, and everything fucking explodes. You know, that could be. In which case, maybe we drop down to double density and try again. Might be the best way to go. Here's what I'm thinking. Here's what I'm thinking I will do in order. Let's see if it gets past the first block. I kind of doubt it. If it doesn't, let's just read the first one and dump it just out of curiosity to see if it matches the first byte on the first sector on the floppy, because that would be promising. And then after that, because that would just be a check that we're somewhere in the ballpark, that would tell us if that matches, then that tells us we're at least reading data and probably not keeping up with it. So I will then try dropping the data rate and the sector count. That's my thought. Does anybody think that's insane? Too bad. That's my thought. So also, I'm wondering, this might be totally off. For final sector of track, apparently the read commands aren't necessarily per sector. They can, like, you can set them up to read a whole bunch of stuff. Because I thought there was separate, like, read track and read sector commands, and I think I guess I think there are, but the read sector command isn't like really read sector. It's like read a number of sectors, so it's actually more flexible. But anyway, so I think this might also possibly be like the last sector to read, which might be a misconfiguration. You know, it might be that I just need to set that to 1. But I don't know. We'll double check that too. Regardless, let's move this on down and try again. Why am I trying to switch cameras? It's already in the programmer. Hit that offset. No comments for me to read. Shame. Shame. All right, now I can change the camera. Cool. All right, I really do. I'm going to give this 50-50. Power on the floppy first. There we go. I knew there was something I was missing. No, not even. So I feel like that means it is almost certainly that we are causing a overflow, and that is causing the command to error and cancel itself, and then our whole drive state is out of whack because we're not doing any error checking, which I'm sure is making Wereworm quite angry. But yeah, so let's do that thing I said, where just for fun, to give ourselves some excite, let's just read. You know what, let me even try as much as reading the first 7 bytes, 8 bytes. Which should we go with? Because the FIFO should be clear, and we have it configured to. I mean, I guess it's actually 16 bytes deep. We're just triggering how deep it gets before it sends us an IRQ that it needs to be serviced. So actually, it could be as high as 16. So I think doing 8, if it is an overflow situation, should be acceptable. So let me replace this with 8, and replace this with DEY, and then we can just look at that buffer. Yeah, I think that sounds pretty good to me. Program it up, program it up. Oodle doodle 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 doo. I feel gooder about this. I'm actually kind of excited because I feel like we should get something. Nothing, really. Now that's interesting. Okay, let's go all the way, remove all looping, literally just try and read a single byte. Yeah, let's do that. Let's move this guy out of here, put it back so I can program it again. Okay, simplify. So, fuck that. That stays. Well, oh, also that was storing bytes backwards, which wouldn't have really been a problem, but was not aware of it. Load Y, so let's load Y 0 again. So that byte gets written to the low buffer addresses first thing. And then we won't even do the loop at all. We'll just try and wait for it to read one thing, just one goddamn thing. And sorry, wouldn't it be funny if it was something stupid like decrease Y doesn't actually set any flags for some reason? I doubt that. There's no way. There's no way. No, that's insane. I will purge it from my mind. Jacob says, I give you 1 byte. And that's my entire file system. It's a 1 byte file system. Okay, it's a very basic system. You know, that's fine. We have 8 whole bits to store data in. I mean, luxury. You could store 2 4-bit files, you know? A lot of room in there. A lot of room. Okay. Hopefully, I actually did all the things right. And if this doesn't go back to the monitor, then we're doing something very wrong and we need to double check how the command is set up, because I mean, you know, like we'll have to check if like maybe you have to wait for an IRQ first before, but yeah, we'll just have to read some code. We'll steal some people's code again if it doesn't, and we clearly aren't understanding what's going on. Anyway, let's do it. Floppy, power on. Wareham said, I don't know why, but I assumed a 4 megahertz CPU clock. I kept saying a 4 megahertz clock, so that's probably why it's in your head. And I don't know where I got that from. I think I just knew it was faster than an Apple II, so I was like, oh, this is hella fast. But it's not hella fast. It's only not quite twice as fast. Power. Okay. So, we did succeed in reading 1 byte of something. All right, what, the low buffer was at, it was 200 and 300. Let me check my code. Let's check the code. Let's check it up, check it down, check it all around. Oh, that's the address. Herder. That's the 0-page address thingy. Pointer. That's what they're called. Right. So the low buffer address was at page 2. So at address 2000, there should be a byte. And then I'm going to go look at what it was supposed to be, even though I have apparently turned that computer over there completely off. Whoopsie. I should probably just go ahead and transfer that hex file I made over there to this machine so that we don't have to keep going over there too. Anyways, 2000. It's that simple. Come on. And dump it. And 00, which seems not promising. Which is interesting because, like, if it had been, if it had been an error code, then one would expect it to be an 80. That's what it's supposed to send. Yes, very. But the fact that it's just 0, just straight up 0. It's like, let's see what 2001 is, for instance. Oh, whoa. What are you doing? Sticky /key. So 2001, because, like, there should just be garbage up in this memory area. Oh, God. Not 2000. 200. I'm a genius. Let's try that again. 200. And let's actually do that again. 200. Now let's dump it. What is that, 40? 40? Are you 40? That looks like a 40. All right, what's the first byte on this floppy? Let's do that other thing really quick. Again, for fun. Are you ready for nausea mode? Oh, yeah. Oh, God. Oh, no. I may have unplugged the camera. Just in case you were wondering what's up. Is it gonna just work? Is it gonna? No, it's not, because I fucked it up. Let me try just restarting it. Maybe. Yeah, I broke the shit out of it, is what I did. There. See? No harm, no foul. We're good. I'm not going to move the mic over there, though, so you're just going to have to watch. All I'm going to do is boot this thing up and pull a file off of it. Actually, I have to plug it in first if I'm going to be real honest. Okay, the question is, do I have a thumb drive and where is it? Do I burn a CD? Is that what I do? Because I have thumb drives, but they're all kind of messed up. I'm going to run upstairs. Have fun listening to the ambient noise in my basement. I'll be right back. I know where a thumb drive is. Okay, and it should even be FAT32. It's in my documents. Cool, perfect. Let's just put these on a flash drive. Does it see the flash drive? All right, I hope that was a fun adventure for everyone. a little flavor. Do I have a USB port on here that's free? That's the question. I have so much crap plugged into this streaming machine. Yay! Look at that. Disk1.hex. Open. Please. That's all I care about. I realize I probably could have just downloaded this disk image again, but I'm not quite confident on where it's from. Anyway, it's wrong. The 0th byte of the 0th sector is EB. Fun. All right, so let's see. What was... Yeah, 1000 was the end of the sector. And it's not something easy and fun like it's the next sector. Okay, so let's think about this. Or actually, let's do this the really easy way. Search for a 40, see if there's one in there, and it lines up at a spot on the drive that would make sense. My guess is going to be probably no. But, like, you know, you gotta try. And it's not like there are going to be a ton of 40s on here, of course. That would be crazy. Like, if I just go through here and there's not really a 40 at the beginning of a sector anywhere, that's going to make me feel like this is probably garbage. One might be inclined to feel. Yeah. No. It's garbage. You'd think we'd get at least the first byte, right? Unless our things are super screwed up. I'm going to go back over here really quick. It's just 40. Let me make dang sure. Here, let's restart the whole thing. Just to make sure I didn't screw anything up by putting in bad monitor commands. I'm sure I didn't. But you gotta make sure. Okay. 0200. Set the address. Read the data. And it's 40. So it's reliably 40. So it's not necessarily garbage. And if we do 0200... Oh, wait. True. 0201. Yeah, that's what I expect, is you get, like, all Fs in RAM or something. So it's definitely a value coming out of the floppy drive. Why is it Garbo? I'm curious to try... Let's go back, for fun, before we just try dropping the data rate, because I would expect to see friggin' something. Let's kill this, and I want to try reading a couple of bytes. Does that seem reasonable? Maybe there's garbage data in the FIFO? I don't know. I'm grasping at straws at this point. But sometimes that's all you can do. So, give me one more try, one more check. See if I can't. You can set it to read less than 512 bytes. Yeah, Dave, I was thinking just 2. So I may do both those things. Let me try just simply setting the re-enabling the loop, but really reducing it. Like Dave said, I'm just going to do 2 or 3. I don't know if this is... I don't know if that's off by 1, but whatever. Well, we can test this. So it's going to be 2, come through, decrease 1, come through, decrease 0. No, that's fine. Yeah, so we'll read 2. That's fine. And then if that's still weird, I will try reducing the number of bytes read to none. None bytes. You know what also might be interesting? So I was told... Where is it? The DTL. So the DTL said this is only used if the sector address is 0, but I read elsewhere that this is what you use to configure the amount of bytes to read if you want to read less than the whole thing. Or more than the whole thing. Or just some weird number of bytes. which is weird. Like, I don't know, it just conflicts with... I'm going to have to read more on this, because I was reading that this is the thing that controls that in general. We'll have to read more about that. Anyway, but we will try that too. So let's do this first. Just try doing 2 iterations before jumping the hell out of here. See if it gives us any more interesting data. See if we get like a crap bite and then a nice bite that we would expect. And if not, we'll try reading up on that bite count control doodad. That's my new approach, because that approach that I described before was on the assumption that we'd at least get 1 good bite. And we don't even get that, so is what I say. No, not that button. I don't even know what that does. I do not understand it, and therefore I fear it. Get on in there. Power you on. And Wareworm said, or you can read and display it in a loop to see if it's at least consistent. I kind of thought about that, but the problem is that alone is gonna significantly increase my time between reading bytes. So if it's a overflow issue, it's still gonna be an overflow issue. I guess it's not like it could get any worse. Oh, Gerald says, how goes the floppy reading? Weird. Yeah, Dave says, will be stored at 2, then 1, but that's fine. Yeah, thanks for reminding me, because I had made a note on that when I was going to do the 8-byte read. Because, yeah, it's counting backwards, but... Anyway, let's see it. Let's see if it does anything. Okay, we read 2. That's interesting. That's interesting. Maybe that 8 was just 1 too many. Maybe that is the thing, is that it restricts the FIFO size. And after 8, it triggers an overflow. Maybe? Could be? Could be, maybe, I don't know. I'm grasping at straws. So 20200 should still be where that is, because it's backwards. That will be our second byte, but that's the one I really want to see anyway. Let us read it. Interesting. FF, that's gross. Fun. What's at 0201? Huh. So it's just giving us shit. Oh, this was the thing I was going to wonder, is with the... This is why I'm curious. I forgot that that's why I was curious as I was talking about it, but this is why I'm curious about this, the DTL. Because if it's set to 0, and that does in fact always control the number of bytes read, I don't know if it does, that would be very interesting, because what if it's just sending us the result bytes already right now? I guess we could match up and see if that even makes sense. The result bytes are supposed to be... yes, I was looking up serial murderers earlier, just in case you were curious. Blanking. I guess I need OS Dev up, as well as the datasheet again. OS Dev FDC. Bit savers. That thing. Yes, yes. Yes, yes. All right, so let's look at the thing. Reading, 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 reading. Read, 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 write. Yeah, 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 yeah. So, yeah, first result byte is STO, and that would be the thing that we had in 201, right? And so if this was result bytes, then it would be ST0 in 201, ST1 would be that FF value we got. So, ST1... Bit 7 instead of floppy had too few sectors on it to complete a read-write. Interesting, actually. Bit 4. I mean, Still doesn't seem like that would be an FF situation, so I'm doubting it. And this also really doesn't look like it describes a couple bits, but them all being set seems unlikely. So probably not that. Thinking about just looking at some other people's code. Oh yeah, let's look at Broken Thorn, because he's the person that I stole it from last time. And they are awesome, so let's just go straight there. Instead of futzing around. Because the point of this is to make it happen, not to futz around with it all day. Boop, 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 boop. Scrolling, scrolling, scrolling to his actual code. Yeah. Tell me how to read. Show me the stuff. Make it easy. I don't want to do complicated things. I'm much too dumb for that. I'm much too dumb for that. Lots of information. All right, read sector. Yeah. This is pretty much what we already did. That looks fine. But yes, see, it does say data length. Does he? Mm-hmm. Oh, the data length parameter byte is only valid if the sector size is 0. So, there you go. Oh. Otherwise, it should be OXFF. Oh, I wonder if that makes a difference. Okay, all right. I want to do that really quick. Just in case. Just in case. Because that is not a thing I had read before. And if that is in fact an issue, it would be really cool if I just made this suddenly work, which it won't. But, you know, hope springs eternal. Off, die, kill ya. Dave's... Oh, Dave is right. You're right. 0201 is the second byte. 0202 is the first byte. You are correct. Right, because I'm doing the decrement after I do the indexing. Thank you. Oh boy. So Derek is commenting on a thing that I have been talking about on Twitter. So about those TXO docs. Or Tixo. I'm going to call it Tixo because that's how they refer to it in like the newsreels and stuff. And it's so cute and 50s, and I love it very much. But yes, the Tixo experimental transistorized machine at MIT. I keep looking at I've been looking at the documentation. Every now and then I look at the Tixo documentation and I'm like, this has to be not too... It probably wouldn't be too crazy of a project to try and build a reproduction, right? And like, within specs, if it's doing like the right things, I should probably be able to like modify the listed circuits to use modern components. And that would be pretty friggin' sick. I kind of want to do it. I was thinking about doing that with a PDP-8 too, especially because you can't get a PDP-8 any frickin' more. You used to be able to. They used to be the PDP that you could get. And now they're also frickin' gone. But now that I can't get that, then I'm just going to go full fat and go with an experimental computer that no one could ever get. Anyway, apparently, so they have BitSavers has some of the Tixo. They have a book on the like block circuits used for you know, like for the bulk functionality. So for logic gates and for like line drivers and things, you know, all the components, the more complex things that are built out of the base transistors. So that's there. So that would be very useful. But they don't have like an overall like block diagram of the machine or logical diagram of the machine on BitSavers. So you can't, wouldn't be able to. It wouldn't be trivial to it would be impossible to exactly recreate the structure of the thing. You could create a machine that uses the same circuits and does the same things, but whether it's the same, you know, as far as how you actually build it, you would not actually know. But apparently, Computer History Museum has blueprints and shit. It's just they're in storage, and apparently they haven't been scanned. And I'm not too serious, Derek, but I was just catching people up on what was going on there because I was searching, and they said I found the page, because they have like artifact listings on the Computer History Museum site, and I joked with Derek saying, "You're the closest. I need you to Mission Impossible in there and get me those." It's also unclear if that facility closed or was closed last year, and they never updated the website to say if it's open again. Really? It's closed during October 2022. Is it a different facility than the main Computer History Museum building? I don't know. I've been there once, so. Okay. All right. It did stuff. I guess I would have been expecting it to go to the prompt, right? Why wouldn't it have? We didn't change that much. But now let's see. So I am told that I should look at 201 and 202. And they're going to be backwards. So let's look at 202 first. Let's do it the way they were written. 0202, set the address, check it out. That is still 40, which is good. We expect that. 0201, set it go. Also 4. Fascinating. Absolutely fascinating. It's just dumping us 4s all day. Well, I guess we go back and look at Broken Thorns code. Anyway, I need to read all this stuff from Derek. Derek said, yes, supposedly the archives are elsewhere, still in my general area, though. I'm not serious. If a magical thing happened where someone convinced someone to scan those and send them to me, for me to ultimately probably not ever do anything with, I would be over the moon, but I'm not even close to serious. I'm not serious unless I am, you know what I mean? But I don't need anybody to go in there and get them for me. It's just, if word got out and someone who was working at the CHM was like, oh, we can get those scanned for you, that would be sick. But they're probably relatively difficult to scan documents, so. Jacob says Nicolas Cage comes in. Hell yeah. All right, let's read some Broken Thorn. Let's get back to it. I didn't really expect that to work, and it didn't. So it is weird that it keeps sending us just 40s, though. Oh, but that actually means, because I was going to say, so it might be sending us status bytes, but I set that thing to FF like I was told, so I shouldn't be getting status bytes already. Anyway, let's read Broken Thorn. Let's read it and understand. Because this command sends an IRQ after completion, we need to wait for an IRQ. He's probably doing it with DMA, which, yeah. First sets up DMA to prepare for a read operation. Yeah. I wonder if I do need to turn on polling mode then. That might be it. Yeah, that might be it. You know what? Let's try that because, well, let me look at this really quick. But that could be it because it was saying you don't need to use polling mode. Polling mode's not. But I'm wondering if it expects it to be done via DMA, and if it's not seeing DMA shit on the on the DMA pins, it's just gonna take a crap. That is very possible. So it sets up DMA, which we're not doing, and then read in a sector, which they do send command. Which I think I am setting that up the same. They are sending the head shifted. Yes, they are sending the track. They are sending the head again. I guess let me side by side this just to make sure that I did it right, or that my shit matches. Oh boy, I can't collapse this because my key bindings are crazy. That's fun. I guess I will just copy this and put it in Notepad. There we go. Okay. So I might want to look back into making sure I set that up right, but read sector command, yes. Send head 0, drive 0, yes. Send track cylinder, yes. Send head, yes. Send sector, yes. Send the 512 indicator, yes. Send, okay, interesting. He is sending for that final sector of track thing. Sector plus 1, if sector plus 1 is greater than sectors per track, so basically if this sector is the last sector on the track, then floppy sectors per track, otherwise sector plus 1. So that is also weird. That is also weird. And then floppy disk gap 3, length 3.5. Firstly, 512, final sector, yes. I mean, incorrect, but yes. And then the gap 3, which I got from the manual, so that better be right. And then FF, which is what they are sending. And then it waits for an IRQ. Interesting. I also wonder if we need to do, because I was wondering how you clear interrupts. And perhaps this needs to be done. But anyway, yeah. So he's not setting up the command in any way that is much different from what mine is. So it's got to be either that it's really expecting things to be done through DMA, or that. What else was it? Oh, well, surely I should definitely fix that sector thing, because clearly what it's saying is if it's at the last sector, then you just put the last sector number. Otherwise, you put the subsequent sector is, yeah. So it would just be, we would want to change this from 18 to 2. But I don't think that's really going to change things significantly. I highly doubt that. But I was wondering about that. So I guess I will at least fix that up. And sorry, I'm just trying to think about the order of things. It's a pain to keep reprogramming this thing, but I would prefer to just like make one change at a time and see if that was the thing that fixed it. You know what I mean? So I'm just going to do this, program it, check it, and then see about changing to PIO mode or turning PIO mode on and seeing if that improves things too. Who knows? But I'd rather do it one at a time, so I know what actually did it. Load up some shit, put it there, program it in the programmer, get the thing over here, grab it out the thing, put it in the thing. That's what we're gonna do. Here you go, into the thing. Here you go, hitting the button. Let's look at chat. Let's look at chat. Derek says, honestly, if it was just a matter of showing up and saying, can I have a copy of that document? I'd totally do it. Well, that's sweet of you. But I think they're expecting actual researchers to go through some sort of request project and spend time at the archives. Yeah, I mean, that doesn't horribly surprise me. I'm glad that they would take things semi-seriously there. I'm sure, you know, these are old documents that need to be handled with care. We don't want to mess them up. Yeah, because it's not like they're just like a freaking Xerox of something. They're probably original blueprints and stuff. Taco Man said, just got back. What did I miss? Had to fix my porch door. Hurricane just keeps blowing it open. Right, I forgot that you are down in the path. That sounds like it's fun. There's a member on my team at work who is down there. And sounds like she's okay, but I don't know. Fingers crossed. And Derek says, CHM is only 10 minutes from my house. Their archives are at an undisclosed location in Fremont. Ooh, undisclosed. Okay, let's see. Let's see what you do. Probably the exact same shit. See, no, what am I doing? O2, O2. Let's try this again. O2, O2. Set address. Print some shit. Wow, look, it's 40. 0201, set address, print it. Oh, it's 4004. That's fun. I don't know. Still seems wrong. I'm going to read some more bytes for fun. No. We have to have a plan. We must have a plan. We got to have a plan. What's the plan, you guys? We probably are too slow. We know that. But that surely is not what's going on here. PIO mode. Let's try PIO mode. Let's do that. Let's do it. Let's do that. Let's do the PIO mode. Or whatever it's called. Pulled IO is, I think, what PIO stands for. We've been going at it almost an hour. That's why my brain feels like goop every time we get here. I remember these notes not being fucking useful at all. Okay, let's just look for PIO mode. That was in configure. Drive polling mode. Disable, which we currently had it set to enable. And that is the low byte of the second parameter to the configure command. So, gotta subtract 1 from the second nibble. Do. Where is the command thingy thing? Where is the configure thingy thing? Configure the floppy controller. Param 1, param 2. So this should just be 4. Or wait. No, yes. It was 5. And it was disable. So we want 0 to enable. Yes. And then FIFO disable, which we did not want, and implied seek enable, which we did want. Okay. That seems reasonable. Again, I don't really expect this to save the day. But at this point, I'm not sure. I mean, after this, we'll just do some more Googling on floppy disk PIO mode. Actually, before I proceed, there was... Sorry, just reading. I believe there was a section on specifically things to do when you're in PIO mode. PIO data transfers. Was it literally just saying that box? No. PIO data transfers. They can either be done using polling or interrupts. Using PIO mode can transfer data 10% faster than DMA. Sure, yes. In general, the controller has a 16-byte buffer. Wants to send an IRQ6 whenever it reaches a threshold. Yeah. If you are using PIO mode floppy transfers, then don't. If you are using PIO mode in a single tasking environment, then the IRQ6s just waste CPU cycles and you should be using polling. You can shut them off, whatever. If you want, you can even toggle that bit on and off for specific commands so that you receive some types of interrupts and not others, whatever. To do them, reset the controller, select the drive, seek to the correct cylinder, issue a sense interrupt command. I probably want to do that. Then issue the standard read-write commands. After you send the command, either pull the RQM bit to determine when it wants you to get shit. Yeah, cool. So this might be it. It might just be that I didn't have PIO enabled. And therefore it wasn't really wanting me to like check the RQM bit for stuff. It was just probably like shitting things out the DMA port. Or, you know, waiting for the DMA controller to do stuff and then shitting itself because it wasn't. So what else do I need to do? I felt like there was something. Oh, the sense interrupt command. So we'll send a sense interrupt command after the seek command as well, just to be careful. But that, yeah, So, after reading that, I feel a little bit more confident that, let's see, applied seek, drive poll, enable. Let's just make sure that's clear. Let's do that. Or rather, let's do this. FIFO enabled. Yeah. Implied seek enabled, FIFO enabled, drive poll enabled. Wait. Implied seek. Oh, actually, that was... Did I totally screw that up? Should this just be 0? Sorry, I realize this is kind of getting off the track here, but... For configure, where were we? Configure. No, that is implied seek enable. Weird. So polling disable, FIFO disable, implied seek enable. Whatever works for you. Right, so there we go. Configure should be fine. And now, after the seek, we should be, actually I have sense commands up here somewhere. Yeah. Is it literally you just send an 8 and then wait for 2? That's what it looks like. So let's just steal that and pop it right after the seek. Oh, I wonder if that's what that, oh, that explains a bunch, actually. Because I was wondering, so in the Broken Thorn code, he had this floppy disk check interrupt command, and he was passing the addresses of ST0 and the address of cylinder, and I was wondering what the heck that is. That's because those are the sense bytes that it sends back. So I'm sure he's doing a sense interrupt after waiting for an interrupt. So I think I should actually be sending sense interrupts all the time. I know, I'm getting bold. I'm really not doing that change one thing at a time thing that I said, but look, we're overhauling it to use PIO mode, and it says to do this for PIO mode, so just get off my back. Sense interrupt. Sense interrupt. And I think that's it, because the seek, any place that I was waiting for an IRQ, I think I should do a sense interrupt to make sure it is cleared. And yeah, cool. I think we're good. I think I'm ready to try it again. I think I'm feeling lucky. Punk. Pop this thing out, read about some shit. Worm said, I was away because my cat just barfed on the carpet. What is a Tixo? Yeah, do some Googling. It's cool. It's basically the computer that the PDP-1 was based on. And you can actually see, I feel like, a lot of lineage between the Tixo and the PDP-8, because the PDP-8 has a very small set of instructions, but it has, if I remember correctly, I haven't looked at PDP-8 stuff in a while, and I'm not a huge PDP technical head guy, but there is like an operate instruction in the PDP-8 that kind of lets you almost do some microcodey things, where you're like using multiple bits to actually trigger some transfers and whatnot inside of the CPU, and stuff like that, and manually control gates, like not like logic gates, but like actual like gates, like muxes in the system on the command, which gives you another big pool of instructions that you can do in a very clever way. And the Tixo, as it turns out, also has that. The Tixo is interesting. Hi, Santiago. What am I doing? I'm programming. The Tixo is interesting, I found, because I had never really read the hardware description before, and it has 4 instructions. That's it. But it's pretty cleverish how it uses them. So it has an add instruction. It has a maybe like a store instruction. Yeah, store instruction. And there's a third instruction. Oh, a transfer control if negative, I think, is the instruction. And which is just like a jump if negative. And then the operate command. And the operate command can do a bunch of things in the way just described, like the PDP-8's operate command can. But the other cool thing that I actually thought was really, really freaking neat from a design perspective was to simplify things, to bootload the machine. It can basically either execute code out of the core, or it can also execute them directly off of paper tape by switching just like a mode switch. And so the guts of the CPU have no idea which one it's being fed an instruction from and cycling on. So you can bootload the thing by just preparing a paper tape that has like a load next thing into the register and store it into memory instruction on it. So you can write a little short bootloader kind of bootloader. I keep wanting to say script, and it's so not the right word. A little boot block type thing that it reads in and just treats it like it's executing commands out of memory, so it doesn't have any special extra like load and transfer shit from tape to memory commands. And then when it's done, yeah, the bootstrap. There's like another word I want to put on it, and I don't know why. But yes, the bootstrapping code. And so it basically transfers manually, has these instructions that say load the next thing, load the immediate value into the register, then store it into memory here, load the next, and that's how it jams the things into memory to get the minimal boot code in there. And then it has a transfer command after that initial thing, and it proceeds to read the rest of the data directly off the tape. So you don't have to toggle in a boot sequence to start reading tape. It just does it with a properly prepared tape. But also by using the same set of hardware for executing instructions and for reading tape. I just thought it was really clever. I thought that was a really clever IPL method. Yeah, IPL is... Yeah, I'm just looking for words that don't exist. Don't worry about me. Here we go. Okay, it's getting late. So I don't know if you, yeah. Let's just pretend that never happened. This is why I tell you, I cannot do chat and also try and program this thing at the same time. Can't do it. My brain is single tasking. Turn the floppy on first. We gotta go after this. I am in no shape. I am clearly in no shape. Okay. I mean, that's not... It didn't explode, but I wouldn't really have expected it to. Here we go. 0202, set the thing, read. 40. 0201, set the thing, read. 04. Okay. Yeah. About that. Let me make sure, considering that I was just like losing my mind as I was rambling there, I'm going to try programming this one more time just to make sure like I actually built the code and it is the proper version on here. I am 99% sure it is. But I'm still going to check. And you know what? For fun too. If I'm going to be in here anyway, hello, I'm going to be in here anyway, then I'm going to bump this up to a count of 4 because I'm feeling crazy. I'm feeling crazy. Okay, linked. We linked it. We did the linking. We linked it. We built it too, actually, in fact, in case you didn't know. Okay, program. change the camera, pull the thing out. Where said, so maybe it's working all along. It's so consistent. You're not wrong, or that it has the exact same failure mode all along, and we're not, we haven't fixed it yet. Let's go. And then I'm just gonna have to call it, because I'm goober brained. Oh, we're gonna start at 4 now, right? 0204, you to do 40. 0204, you to do 40 again. Oh, because I typed in 0204 again. Wow. 0203, you to do 04. There we go. 0202, you to do 10. This is interesting. 0201, you to do. Yeah. I don't know what this means for us. Are those status bytes? Bits? Status bits? Bytes? How many status bytes are we supposed to get? Okay, this is the last thing I'll do for the night. Here's the last test. Let's try, let's see, how many status bytes is this command supposed to return? I still think it's insane if it's just straight up returning us status bytes, because it should do something in the middle. It should do something. Ooh, actually, you know what is a interesting and quick test that I can do? I'm gonna open my... Oh lord, what did I do with that? Hex file. It's right here. Let me just, I doubt I'll find anything, but let me just search for that string right now. So the string was 40041000. 00, right? Not 88. 00. 40041000. I bet I won't find it, but it will be interesting if we do. 40 04 10 00. That's interesting. That's not right, but it's interesting that because this is the address, so it's not part of the data. Anyway, I guess let's see if there's another one. Probably not. Match 1 of 1. Yeah, no. That is kind of fascinating and hilarious that this string does exist in here, but because it's part of the interesting. Right. Anyway, what I was gonna do, ignoring that, keeping it in the back of my head, but otherwise ignoring it. So the number of result bytes that we were supposed to get is read. Where is read? Read right. So we get 1, 2, 3, 4, 5, 6, 7 result bytes. I'm going to try reading 7 bytes, just out of curiosity, to see if it's our 7 result bytes, for no good reason, like that it's not sending any data and is just sending us result bytes, which would be weird, but I think worth testing, because it's clear it's sending us values of some sort. Like Wareham said, it's so consistent. It's so consistent. So could be result stuff. Maybe there's more we have to do to enable PIO mode. You know, like maybe I mean, the DMA controller would realistically have to be driving it to, you know, be emptying the FIFO and stuff. I don't know. Maybe it's that we're too slow even reading the first byte for some reason, or, you know, I don't know. And it's like failing and just right away sending us the status bytes. Fuck if I know. But let's try reading them, seeing what they look like, and seeing if they look roughly like what we'd expect, and also, if we're not sure, up it to 8 and see if 7 works and 8 doesn't, because that would mean similarly it would give us an indication that it's just the status byte, or yeah, status bytes. So I don't know. Shooting tin cans in the woods here. What am I doing? Turning this off. All right, we're gonna do this very slowly because of my aching brains. Take this out, put it in the programmer. Very good. Go back to the code. Make sure it's written. Build it. Load it. Okay. Program it. Program it. Okay. Take it out. Put it in. Lock it in so it cannot escape, even if it wants to. And hit go, and hopefully we'll see a prompt, and then maybe we'll see some interesting data. Nope. No. See, this is why I have to do it step by step. Power on. Power on. Okay, interesting. So it did read 7 things. Let's go through them. I'm just gonna, you guys can get, like, look at it and get excited if it looks reasonable, but I'm just going to very slowly type these in one by one and look at my fingers as I'm doing it. 02, 07, 02, 06, 02, 05, 02, 04, 02, 03, 02, 02, 02, 01. Aha! So already, I feel like that is our status stuff because, let me show you a thing really quick. I'm going to look at them and I'm going to do some more confirming, but, ooh, look at that nice screensaver. Let the retro soak into your soul. Anyway, right, so on the documentation here, you know what the 7th result byte is? It's 2. Maybe a coincidence, maybe not. All right, let's read this through. So the first thing is STO. So if 0207, if this is them, 0207 is 40. STO, I mean, they couldn't have just written this reasonably. Let's see if this is written better in the documentation, because like they're trying to do just like textual descriptions of the thing, and I just want to know what bit positions do what. So I guess Control F, STO. Nothing. Is this even? Nope, it's selectable text. STO? No? Really? Interesting. Anyway, let's see in the commands what it describes it as, because it will describe it as something for sure. Hello? Hello? Commands, where are you? Did I miss you? I sure did. Here we go. Oh, there you are. Read, 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 where, here. That's read track. You almost tricked me. Read. Okay. Oh, because they put a friggin' space in it? Nice. STO, ST1, ST2. STO, ST1, ST2. Thank you. They are the status registers. Good to know. I think they are described elsewhere. But let's scan. Let's scan. Control F, STO. Really? Really? ST. Okay. What the fuck, dude? Status register? which we're going to get the status register A and B and whatnot. Status register encoding. Section 7.1. This is the world's slowest document. Here we go. Status register encoding. See, this is what I was looking for. So, if it is 4.0, that means that these are 0. Yes, so these are 0, which we selected drive 0, so that makes sense. Head is also 0, so that would be fine. Unused, and this is always 0. So the lower nibble being 0 is good. Equipment check. Track 0 pin failed to become a 1 after some things, so we should also expect that to be a 0, unless something went horribly wrong. Seek end is after a seeker recalibrate, or a reader write with implied seek, but we already seeked, so I can see that still being 0. Or wait, no. Wait, no. Right, because implied seek, well, anyway, sorry. No, that's the, slow down, just slow down. This is the first bit of the second nibble, this is the second bit of the second nibble. Bit 6 is the one that is in the 4 position. Blah. Okay, so this is 01. Oh, interesting. That's good to know. Okay, this might actually be reporting some information to us. 01 is abnormal termination of command. Command execution was started, but was not successfully completed. So, yeah, that's cool. That jives. If it's telling us abnormal termination, then yeah. All right, let's keep going on then. What, it was 04 was the next one, right? Let's see if this lines up. What am I doing? 04, yes. So that ST1 is 04 a sensible value for ST1. So missing address mark would indicate that there's a problem on the disk. We don't expect, 0 is fine. Not writable is if the write protect pin is high. I don't think that is the case, so it being 0 is fine. Interesting. So this is the 4's place. Any one of the following: read data, read deleted data command did not find a specified sector. Interesting. Interesting indeed. So I think somehow our command is still encoded incorrectly, if this is to be believed. This is 0, it should be 0. Becomes set if it doesn't receive CPU or DMA service within the required time interval, but I don't think this is an overrun. I think this is a different thing. It didn't find the sector in the first place. So the fact that this is 0 is reasonable, I think. Data error would be that there was a CRC issue. We wouldn't have gotten that far. 0 is fine. This is always 0. And end of cylinder, tried to access beyond the final sector of the track. I wouldn't expect that either, so that being 0 is fine. And this jives too, so I'm feeling like this is right. Wareham says, is the floppy DD or HD? It is HD. 100%. I double checked that. All right, status register 2. What does the box say? That is a 10. All right, status register 2 is so 10, right? So we expect the whole bottom nibble to be 0. Cannot detect a data address mark or a deleted data address mark. No, it's not that. That's fine. The track address in the sector ID field is different from the track address maintained inside the thingy. I guess that's fine. 0, 0, so I think it's reasonable if these are all 0. Wrong cylinder. Oh. The track address from the sector ID field is different from the track address maintained inside the 802077. Mm-hmm. So maybe we sook. It's weird. Though still, that is odd because... No. I was going to say we sook to track 0 and there is no track 0. No, there is no sector 0. Damn it. Anyway, wrong cylinder. That's also believable. And then I wouldn't expect a CRC error, and I wouldn't expect a deleted data address mark. Probably. I mean, it makes sense if that's 0. And this being 0. Cool. So again, if this is believed, it makes sense. And the thing that we're being led to believe here is that the cylinder, the track address from the sector ID field, which I believe is the sector ID field on the floppy, is different than where the controller thinks it is. That's interesting. Okay. Let's keep going. So far, seems believable. Continues to seem believable 3 bits in. And then I think after that, status registers are 0. Dave says, are you waiting for RQM to be 1? Yeah. Yup. We last time I actually spun that off into a subroutine. So every time we do a read data or a send command, we're waiting for RQM. We are. Right, so anyway, I think that's all the status things. So the next one is 0, 0, and that's like head or cylinder, because the next ones are what head or cylinder or whatnot did we land on when we were done. Let's see. Hello. Read rate. Yep, so, okay. So the next one should be the cylinder number. 0 is acceptable. Ending head number should be 0. That's fine. Ending sector number is 1. That's fine. That matches exactly. And then the last thing is 2. So yeah, these are our status bytes, and it is telling us we are not... Basically, I think it's telling us that the cylinder that it's reading on the floppy is not the cylinder that the floppy thinks it's... or that the controller thinks it is seeked to. So, we'll leave it on a cliffhanger with that one, ladies and gentlemen. But I think that is actually some really interesting progress. That, I mean, 100%, that matches what we would expect for status bytes. It would be weird for it to line up that perfectly. And I already tested reading 8 earlier in it, and it hung, which would make sense. Wareworm says, Wareworm, it's a fucking weekday, and it is already 10:13, and I have to go do other work. So, yeah. Sorry. But look, we have a thing that it's telling us to do. It's telling us something's friggin' wrong with your cylinder versus where I am versus what's on the floppy. So, that's a thing. That's a thing. Would be interesting if like our tracks per inch number, which is not what it's called in the floppy or what it's called in floppy terminology in general, but you know, how many tracks over a seek does would be weird. I'm not sure if there's actually a setting for that, but maybe it's that. Maybe we're like, it thinks it's seeked to a track that it's like, it thinks it's at 0, but it's actually like not at 0. Or something similar weird like that. Or I don't know, could be that this floppy is weird, and for some reason the cylinder marks on the drive are bad. I guess I didn't really read it back to see if it's readable. So, many things it could be. Anyway, I'm going to stop rambling. It's time for me to go. I have put in my hour and a half for the day. And thank you for coming, one and all. And we will get back to this tomorrow and figure out why the cylinder is not jiving. But that's still pretty cool. I'm pretty happy with it. Until next time. Oh, the camera's over here now. That's called a bookend. Until next time, see ya. Love ya. Bye. Goodbye. Bye. Bye.